Well, hello, welcome to this episode of TurboShed, and in this one we are going to fit a Haltech Elite 2000 with Elite wiring harness. Well, there's an awful lot of work in putting one of these into a Lexus. The reason we've gone for the Elite 2000 and the Haltech is that the support and the information on the web and the software and everything else for the Haltech appears to be the best on the market, in our opinion. And the Elite 2000 is the first one in their range that does full sequential injection and ignition for an 8-cylinder car, like this one. So that's why we've gone for the Elite 2000. We could have gone for the 2500, which is the next one up. But really the only thing that offers that this doesn't is drive-by-wire, and we've got a throttle cable, so we don't need that. So this is what we're going to do. We've got the premium wiring harness that comes with it, so we've got the fuse box. There's 4 fuses as standard in that and 2 spares. So one's for EFI, so one does the injectors, one does the coils, one does the fuel pump, one does something else. Oh no, so one we're going to use for the thermofan, and we've got a couple of spares which we'll use for the auxiliary fuel pump and things like that. There's an awful lot of wires, and somehow we've got to splice it into this harness. The other thing we're going to have to do is we're going to change over to coil on plug when we do this as well. I've already made part of the standard engine harness based on a standard Lexus one. So I've wired in the coils, and the injectors as standard on the Lexus are wired in pairs, so there's only 4 coil outputs to the standard ECU. So I have chopped and changed that and done it so we've got 8 injector. So the injectors are all separated, and we've got all sorts of other bits. So the first thing we need to do is we need to get the standard ECU in the car and trace some wires that we're going to have to use for the Haltech, which basically are the plus 12 volt power and the power when the ignition's on. So we can use those and tap into that, and then what we'll do is we will slowly work our way through. We will pull the standard harness off the engine. We'll put on the other harness that we've got, and we'll work our way through this absolute bunch of wires one at a time and get them all connected. It's going to be a long few days, I think. So here's our spare engine, and what I've done here, you can see that I've mocked up all the coils. We're going to use the standard wiring runs because that keeps everything neat, but I've done all sorts of things. So these are Yaris coils, and you've got to add in a spacer. That space is about 12mm off the top of my head, and then they fit straight in. We got some plugs, so I've wired that in, and we got various sensors. So crank and cam. So obviously cylinder number 1 is front left on the Lexus, but actually I'm going to use the right hand cam for the home signal, and the reason for doing that is that the our turbo is here, and you can't actually get to that sensor, so if anything goes wrong with it you've got to take the turbo off to change it, so it makes sense to use this one. So I've cut down the standard cam bracket. So crank signal, cam signal, they go into here. You see we've marked everything up. All of our injector connectors, 8 down both sides, all our coil on plugs. What else have we got? We've got these here, which are going to go, we've got a fuel pressure sensor in the fuel rail and a water pressure sensor, so I can make sure it's not blowing boost into the water. We are getting rid of the airflow meter and changing over to manifold pressure, because the Haltech already has a connector in for that. So this will be our inlet air temperature, which will go in the pipe instead of the mass airflow meter. Here we are. There we are. So that mounts about there on the engine and takes the place, that straight pipe takes the place of the standard airflow meter. And there's our air temperature sensor, standard GM one. What else have we got at the back here? We're going to use the 2 standard NOx sensors and the starter. They're actually on a separate harness. So we are going to keep those in the car, because otherwise you've got to take the inlet manifold off to get to them. So I'll actually just wire them in and not bother changing that part of the harness. It's on a plug, so that makes it easy. And after all that's wired, we end up with this. So this is the standard harness bulkhead connector, and these wires here, which you can see I've marked up with tape, and every one of these goes to something on there. So there we are. So we'll take this harness off, and actually we'll put this harness onto the car. So we need to go to the car, mark up our wires for the ignition, and then we need to strip all the wiring out of the car. This is a one-way trip. This is all 7 pages of the standard ECU wiring for the Lexus, and what I'm interested in is this ignition main relay here, because this is the one that sends the power to the ECU and such like. And we have the circuit opening relay here, fuel pump control relay. So we're going to use those and wire into it. Here's the starter circuit here. But what we need to do is work out which wires are going from here over to the ECU, which is this part here. Well, that's the ECU connector. So we will trace this through and have a look. So I think we worked this out. We've got the ignition switch here with the 2 positions, so ignition on and start. So the start is pretty simple. That goes through down into this starter relay, so we can take our Haltech start signal off here, which is B, which is brown or black, I can't remember. Anyway, brown or black, we'll find that one at the starter relay. And the other place we need to go is we need the 12 volt when the ignition's on, which goes through this circuit open relay, which is the one that switches over and keeps the power live when we start and ignition. This is a bit more complicated because the start signal when it's cranking is wired right in and goes straight to earth, so that's dead easy. So we'll have this relay closed when we're cranking. But the ignition one's more complicated. The ignition one runs along here, down through that 7.5 amp fuse, into this relay, and it then goes off to the ECU. So what we're going to have to do is find this wire and ground it, such that whenever we've got the ignition on, this relay's closed, and that will give us a relay plus signal. This is our power, so that's okay. Our power source, which comes from the EFI main relay. So that's okay, and then we can tap into this side of that circuit open relay for the pink, which is the signal on for the ECU. Right, so we need to pull the ECU out of the dash, and we need to trace these wires because they're our initial power ones. The ECU is hidden away under here, so we'll just take this off. You can see the connectors there and the wires, so we'll pull this off and find out what we've got underneath. Right, here's the ECU. So we've got the connectors, 26 pin, 16 pin, 22 pin and 26 the other way up on the sticker here. So all we've got to do now is find those wires and check them with the multimeter, and then we can start marking them up and connecting the Haltech in and pulling these out. Right, we're getting somewhere. This is the EFI relay location on the standard car, but we need to bypass that because we're not going to use the standard ECU obviously. And this is the circuit open relay, which is the one that makes sure there's power on when we're cranking and when the ignition's on. So we need to keep this relay, but the power from that comes from the EFI relay, which is switched by the ECU, which is going. So that's a bit of a circular problem. So the easiest way to fix that is to find connector B, which is the one with all the short wires on, all the thin diameter wires on the ECU. And if you take the pin 26, which is the bottom corner, just for info, looking at pins end on, top left is always number 1. So it's easy to find, which is a black yellow. That's switched from a 7.5 amp fuse in the fuse box, so that's good. And if we then take the circuit open relay feed, which is this black red, and we connect those two together, I'll solder this up in a minute, that means that we have a fused feed to the circuit open relay, and we can use that for the signal for the ignition and cranking for the Haltech. The only other change I've done is that this has 2 coils in it, one for ignition on and one for cranking, is that we need them both to operate without the ECU. So you simply take the 2 thin wires and connect them together, connect the green into the white black, that goes back to earth, and that means that we've always got power. So if I solder those 2 up now, then we can use the feed from this green one, which actually goes to the fuel pump relay, which we're not going to be using, and then we have all our feeds. That will do the cranking ones, and on the back of the main isolator breaker here I can connect all the live feeds in for the Haltech, and that means we've got power to an ECU. So let's get these soldered up, connect those in, and then we can actually turn the ECU on and start working through the rest. Well, we're ready to put the ECU in. So all I've done is made this steel plate bracket here, so it mounts the ECU off the inside of the dash. So when that's closed we won't be able to see anything, which keeps our sleeper look. So that's it, we are mounted. It's now time to put the Haltech harness in, start wiring it up, and put a map in, and we'll work our way through one system at a time. That's the harness, there's the relay box which we'll mount later, and now we're just going to sort this lot out. So I've just put a cable tie in here to terminate the harness and hold it all steady so I'm not pulling on the connectors from the Elite, and there's a bit of a loop in there so we've got some extra wire. So what we're going to do now is work our way through these one by one. The first thing I want to do is to sort these out. So these three from the Elite harness one is the main plus feed for the ECU, and the other ones are for the relays. So they all go to the fuse box, so the best thing to do is to wire those into the battery isolator switch. So they're easy, that'll be done. And I need this one, which is the black, which is the earth. So we'll take that straight back to the battery, so we know that the earth on that is perfect rather than go to a body earth. And the other one is this, which is the pink wire, and this one goes to our control relay, which we wired up earlier, so it's live whenever the ignition's on and whether it's in the start position as well. So if I wire those 5 wires up, it means we will have power to the ECU, and that means that I can plug the laptop in and put a map in, and then as we work our way through the sensors in this lot one by one, I can test the systems as we go. So I think that's the best way to do it. So here we go, let's do a bit of wiring. So this is the back of our battery isolator switch, and we have our 3 red wires here all crimped on onto there. So that's it, we have power to the ECU. Next job, let's run the ground and connect in this pink one, which is the switched the switched power. So that's that one's done. So onto the pink one now. This is the 12 volt switched, and once that's wired in we can plug the laptop in and fire the ECU up. Well, I've plugged the firewire cable into the Haltech, so we're plugged in here, and I've got the software loaded on my laptop here, so we'll plug this into the laptop. Let that sort itself out and put some power on. And let's see what we've got. So what I've done is I've pulled all the relays out of the relay box. So that's okay, we've got power on. So this is the ECU one, which is the left hand one. We'll plug that in, that clicked. And we have the power LED on the Elite. So we have power. And let me go to this and press connect, and there we are. That's loading the map there. The reason I've got to put our base map into the ECU is obviously all our inputs and outputs are configured to how I want to wire it, so I need to make sure that we've got that right. So that's just loading the map. We've got ECU connected down the bottom here, and there we are. So that's in there. Oh, we must have signal. We've got battery voltage of 11.86. So what I'm going to do is I'm going to open my map, which is on here, and I will upload that to the ECU, and then we'll just check and make sure we got comms, which I think we have. I think we're okay. So that's it. Let's start wiring some sensors. Now we've got that in. The ECU, no. Turn the engine off and the ignition and back on again. Right, let's do that. Right, sorted. So we've got those settings there. I think we'll wire up the throttle position sensor and the 5-volt sensors first, because then we can check that they're working. When we've got all the other relays out, so nothing's going to work on there. Right, time to do some more wiring. Well, really the next job we've got to do now is I've got to take off the inlet manifold off the car and strip all of the electrics off the engine, because we're going to use our other harness. So the only thing that will be left on the engine will be the 2 knock sensors and the signal wire to the starter motor, because we're leaving those alone. Absolutely everything else comes off: coils, igniter boxes, airflow meter, and all the other harnesses and sensors, because we're going to transfer the harness that I've half made off the other engine and then splice the two together. So no point looking at it, we might as well just get on with it. Well, here's the harness off our engine. There's the ECU plugs and the ones for the rest of the car. So basically there's almost none of this we want. The only thing we need is this connector here, because that's the one that's got the connections that go to the knock sensor, on the knock sensors, and also the starter motor. And obviously they're not part of the engine harness. So what I need to do is to take this part of the wiring out, because we can keep that, and everything else is going to get chopped, and then we will put this bit of the harness into our other harness that we made, put that back in the car, and then start wiring it into the ECU one section at a time. So anyway, it's good to get that out, and as you see, you've got to take the top of the engine off to get it, and there's an awful lot of wires here that aren't going back in. Here we are, this is the bit of the harness we wanted. So here's our three connectors, three pins, one for the starter and one for each knock sensor, and I've cut that out of the harness. So I've kept this connector here which goes into the body of the vehicle, because that's got the starter connector on it. we don't have to do anything else with that. And here's our knock sensors, and obviously they've got earth leads because they're shielded cables, so I need to connect those into the Haltech, so they'll go directly into the Haltech. So that's it. I can put this section of the harness into our other section that we've made, then we need to put that back on the car and start wiring it up. Well, you can see we've pulled everything off now with the wires. I've just put some new seals on the injectors because I didn't have those earlier in the last video, so I did that while they're easy to get to. And we have our new wiring harness that we made on the dummy engine laid out here. So this is laid out as it is on the engine, so we've got left-hand coils and injectors here. We've got the centre section here, which is for the idle control valve. That's the only connector that's left in that section. Down the right-hand side here we've got coils and injectors again for the left bank. And these are the wires that we need to splice in, and I've labelled them all up. So I think it's a case of lay this in the engine, and then we'll start. We'll connect up the 5-volt feed and the earths for the sensors, and then see if we've actually got any life and readings in the ECU. So we're going to change over to coil on plugs as part of this process, and these are Toyota Yaris ones. And actually, if you use a 35mm M6 bolt, an aluminium spacer, and that spacer is 12mm long, we just machined those up on the CNC. These coils and the bolt on the coil pack there lines up directly with the old plug locations, the plug lead guides, except for the front two, which you're going to make a couple of little brackets for. So dead easy. So we'll get those coils put in now and get those connected up, and then our engine harness is connected, except for the crank and cam sensors, and we'll see if we've got signals. And there you can see the coil packs. 3, 2, 1. There we are. You can see the coil packs running down the sides with the spacers in, and you can see we've got the aluminium bracket there. Go to the other side. There we are. There's the aluminium bracket for the front one, and the spacers all the way down. That's it. Our coils are in. Sorted. We shall tackle this lot now. So here's the harness and all the wires we've got to connect up. What I'll do is I'll connect them in the engine compartment because we've got some extra loom here. I'll poke them through the hole at the far end, which I'm not sure you can see. And up here, this is our firewall grommet, so I'll terminate them on the car side of the firewall grommet. And these are the first ones we'll start with. So this is AVI 10, which is the throttle position sensor, which is 5-volt on the orange, earth on the black, which is from the ECU earth, the Haltech earth, not the car earth, and the white is the signal. And I've got my 3 wires here from our sensor, which I've marked up: TPS signal, plus 5-volt, and TPS and ECU temp earth. We'll connect those in, and we're starting to get somewhere. So this is part of the screen that we've got for the Haltech, and this is dead easy. So I've just set some parameters up here. So I've done something a little bit different for the cam position sensor, because we need the crank sensor, which is the trigger. I think off the top of my head it's got 6 points on a star for this, but it's already programmed as a standard map into the Haltech. And we need a home signal for the cam, so it knows which side, which stroke it's firing on. Now usually you'd use number 1 bank, which is the left on this, but we can't get to that because somebody put a turbo in front of it. So I'm actually going to use the right hand bank and time it off number 2 and just use the offset angle in the Haltech in order to get it to calculate back onto number 1. So this is the standard cam sensor, but as standard it has the distributor mounting on there as well, and I've cut all that off just to make a small bracket there, and with it being on the right hand bank it means it's dead easy to get to, and we can do maintenance or whatever else we need to without having to take the turbo off. So that's it, that's all cut, and we'll just pop this on. There you go, you can see that in place there. This is the bracket, so this is the connector for that cam signal on the right. The crank one is down there. I know it's near the exhaust, but I'm going to leave it like that until I've set it up and make sure it's working. And we've wired these back into this multi-pin, which was the standard one. So all we're going to do is connect this up. There we are, everything's clear of the belts, so now I can wire up the cam and crank signals and the shields for those onto the ECU, and then I need to turn it over and make sure we've got those signals working and do the ignition timing. I've wired up the shielded cam and crank sensors now, which all come into this socket here. So I need to spin it over. The top right hand box there is RPM, so I've just put this wire in on the solenoid for the solenoid switch. I'll just short this across here, and if I touch this on here we've got an RPM signal, so one of our triggers is working. 150 RPM, that's about right for spinning it over. Right, I need to wire up the ignition coils now, and we can set the timing. Well, we've wired up all the injectors, we've wired up the ignition coils, we've done the wiring for the fuel pumps, so that should be enough so we can set the timing. So the way you've got to set the timing on this is that we've got to spin it over, and we've got to set the crank angle so it knows where top dead center on cylinder 1 is versus all the sensors. So I think you need to get the first thing we'll do, we'll just turn the key and make sure the fuel pumps are priming. Yep. Because that should be okay. And then we'll spin it over and we'll see what's going on there. So let's do that first. So do you want to go and turn the key, Leon? Yep. And I'll have a look at the fuel pressure and we'll listen to the pumps. And hopefully we've got no fuel leaks and we have the pumps priming. Ready? Yep, when you're ready. Yep, that pump's running. Yeah, that pump ran for, what, 3-4 seconds, didn't it? Right, cool. Well, I've already got the timing locked. So we've locked the timing at 0 degrees on the laptop. So we've got the laptop set up, that's connected to it. I'm just going to go into the settings and turn the injectors off. That's it, injectors are disabled, and the ignition, I have the timing fixed at 0 degrees, always on. So that's that done. Oh, that wire's just come off. So let me plug that on there, which will give us a spark signal. I've got the strobe. Right, Leon, if you'd like to... Oh no, you don't need to. The ignition's already on, isn't it?
Yes.
Right, okay, well I'm just going to bounce this across to run the starter. Injectors are disabled, so it shouldn't start. And let's see where the timing is. No, we're not quite right there, so we'll adjust it. That's in the trigger page, TDC offset angle. We'll set that, I don't know, it was 70 as standard. We'll set that at 20. Give that a go. It's not far off. What do you reckon, 26?
Yeah, something like that will do. Maybe that's it on the crank.
Let's try that there. Oh yeah, we've got fuel pressure readings and stuff, that's good. 5 degrees air temp, tropical. That's it, we're on 0 there. I quite can't see that one. It's running a bit too slow on the strobe, but that's it. We've set our firing angles. Do you think we're ready to give it a go, Leon?
I think so. The ignition's on.
Right.
Just enable the injectors.
Let me turn the injectors on. And let me set the ignition timing so it's free to run. Not whatever it wants to. Right, can you turn the ignition off? Wait a few seconds and turn it back on, please. And while Leon's doing that, we'll just say that we had an absolute nightmare getting this thing to spark. We could not get the ignition to spark. And I spent a day looking at coil wiring and everything else and all the settings in the ignition tab, and it turned out that all we had to do was to put the injection relay in and connect one of the injectors up, and the spark was there. So that drove us absolutely insane. Right, Leon, we've got fuel pressure, we got volts, and I think we've got spark, and I think we've got injector. So let's give it a go. Sounds pretty good. Turn it off. Off.
Oh, hey! Right, so it starts. That means the fundamental, we've got 8 injectors and 8 coils all firing where they should be, which is perfect.
We might not have 8, but we've got some.
It sounds like it's got 8, but it's running awfully rich, so it's time to put the O2 sensor in and get that mixture sorted out so it doesn't look like a 2-stroke.
So this is our wideband lander controller. This is actually one off my dyno, which we're going to borrow for this project. So it's a Bosch heated oxygen sensor there. We have power wire connects here, and then we've got the signal from here. And whatever the air fuel ratio is, it goes from 0 to 5 volts output, linear 9 to 19 on the AFR. So this should do just perfect for putting into the Haltech, and it'll allow us to get the mixture sorted out. Perfect. Right, so we'll take the old one out, the exhaust downstream of the turbo, and put that one in, and then we'll do the wiring and see what we've got. We have our Bosch, it's a LSU 4.2, that sensor's down there, so that's hidden out of the way. We've run the wiring, and here's our controller. It's just temporarily on there so I can see it and see what's going on. So this is a Sport Devices one, it's an LSU 4.2 for the Bosch, so that's wired into the harness now. And I'm just doing the boost controller because we were just running wastegate pressure before, so we've got this pipe here that goes directly from the compressor outlet there, so that puts the actual intercooler or inlet pressure onto the bottom of the diaphragm, and we've only been running spring pressure. So what we've got to do is, yes, I know this is a Haltech boost control solenoid. I've actually got a Mac one which I think is exactly the same but without the Haltech sticker. All we do is we connect this up here, so there's only 2 connections that we need. So we've got 3 ports, 1, 2, 3. So the next exciting bit, we've got the Haltech rotary trim module here, which will allow us to adjust boost and maps and such like while we're driving. So I'm going to fit this into the dash here, so we'll just put a hole in there. You can see the switch in there, 12 position switch, and that'll give us all sorts of settings, and we can mess about with that. Well, I've just started it up so we can run it up to temperature and make sure everything's working okay. Radiator's still cold, so that's just getting warm. I think the thermostat might have just opened. So everything looks good, it's running nice and steady, and obviously being a Haltech closed loop learning, it is, if we look at the computer in real time, here we are, you can see this blue dot here, that's the one that it's working on. And if I look at the main parameters and we look at the lambda, that's 14.6, 14.7, which is exactly what the target should be. And if I go back to main, we can see that we're currently running 900 RPM, so the idle control is working, and at the manifold pressure that we're running at, which is in this box here, 1000 RPM, you can see it's minus 5.7, so it's taken some fuel out of that box there. And obviously the idea is that long term we'll run our way through the whole of this box, and we'll see what's going on. I need to do the knock sensors. You can see it's picking up knock there, but at an ignition angle of 10 degrees. I very much doubt that's correct, so I need to go and actually calibrate the knock sensors because I haven't done that yet. So yeah, we'll sort that out, and to do that we just go into here, into knock control, oh sorry, knock detection. There we are, knock detection, and we should be able to see both of our knock signals running in real time. I think we're finished. I think we've got the Haltech wired in, we've done all the wiring, we've tidied everything up, we've done lots of other jobs. Leon just took the inlet manifold off earlier, and instead of having all the vacuum pipes with bolts stuck in them and the rubber pipes and things, we pulled all the steel ones out. We've threaded them all, we've put bolts in with Loctite, so that's all sealed up properly. We've tidied up the wiring a bit, but we've left it exposed because we just need to make sure it runs okay first. And the next thing we need to do now is we need to run it, and we need to put some load in, and we need to allow it to map itself and just check everything's working correctly. That's it. I think we have installed the Haltech. Everything seems to have gone well, and tomorrow we are booked in at Teesside to go and run the car in between other sessions, so we can just put some load on it and slowly build it up, and hopefully that'll go okay. So the way I'm going to do this, I've got the laptop here. Unfortunately Leon's not here. This is much easier with two people, so one can sit in the passenger seat and do the laptop. But all I'm going to do is drive round and round and round the circuit, steady. We are slowly going to build up, and I'm going to build up the load and basically sort out the Haltech. I've got a conservative ignition map in, and we are going to map the air-fuel ratio and get that somewhere near and work our way up. I've got the boost controller disconnected, so we're running on spring pressure, so it'll only run to 7 psi because we knew it ran okay at that. So basically what we're going to do is I'm going to try and get this air-fuel ratio somewhere near and mapped up to 7 psi. If that works, I will plug the boost controller in, which will immediately give us 10 psi, which is more than we've ever run. And if that's okay, I will start working our way up through the boost levels until we run out of injector, or I get frightened, or a bit of both. So first thing to do, I'll stick my belts on. I've got the laptop sat here, I'm going to put on the passenger seat, and we will give it a go. Well, I hope you can hear me over the noise of everything. So what I'm going to do is, we're recording this, so I will, where are we? Yep, we're recording this. So I am going to go to the fuel, I'm going to go to the long-term fuel trim, and we will see that we've got the blue dot there, and that tells us where we're running, and this map here will tell us what we're adjusting. And while we're doing that, I am going to keep an eye on some important things, like the lambda, which is top right here, and that's going to tell us what we're running. So, oh, that's the target lambda, and below is the actual. So let's run and see what we've got. We're up to temperature. All I'm going to do is run this round slowly on low throttle, and we're slowly going to increase the throttle position as we go and let it map itself. Our target lambdas are looking pretty good. You can see there it's weak, and it will richen it up as we go. Got a left foot brake a bit to put a bit of load on it because I don't want to rev it too high. I want this to sort itself out. Now that lambda's looking good there. reason the idle control seems to have stopped working today. So let's have a look and see what that fault code is. Oil pressure too high. Right, 3, 2, 1. Well, I think we are getting somewhere. So what I've done now is, forget that, I've just connected up the top of the wastegate to the boost control solenoid, which is here. I think I've done as much as I can with 7 psi, so I've put this on, and our lowest setting now is 10 psi. So let's go and see if this is holding boost at 10 psi, and if it is, then our boost controller is working and we can get on. The only thing I've had to do, you can see here, the idle control valve isn't working, so I've just blocked off the idle control pipe for now to stop it ticking over at 3000 RPM. Right, so there's our target, there's our actual. Let's go and see what goes on. The fan's on, coolant temp is 80 degrees, yep, we're all good. Slowly roll the throttle on the straights and control the boost with the throttle until I know it's doing what it should, and then hopefully the boost control target map will start learning itself. Up to 2 psi now. 4 psi. That's okay, steady at it. Be much better on a track that wasn't so twisty. So I just need to pull the boost up further. Well, I'm afraid that's it for the Haltech video. I know it's been a long one, and believe me, that took 5 days, and we've compressed that down to a few minutes per day on the footage. I was doing the car mapping by myself, which you saw, and that was a struggle, and I was having trouble with cameras as well, which is why we never captured the end. But the end result is, as we were going round and round and round. I was slowly getting faster. We've wired in the Haltech rotary switch. And one notch on that, so number 1 on there is 10 psi boost, and every notch you go up goes up 1 psi until it gets to 18 psi, and then it's got the same map for all of it, so we can change the map while we're driving. And basically where I got to was that I got up to 16 psi on the boost, and I couldn't actually run any more. The reason being is that you need to hold the throttle down for 1 or 2 seconds above 75% for it to start mapping. For the boost control. The problem I got is that even in 4th gear with new tyres on the rear, so I had as much grip as I could get, at 16 psi in 4th gear it was breaking traction when it came onto boost, and I couldn't keep the throttle down any longer. It was a little bit sideways, let's say. So I've only mapped it up to 16 psi because I didn't have any more grip. But it ran fine up to there, so we've got a couple of niggly little jobs to do, like the idle control to fix. We're going to get that sorted out, and we're going to get the car ready for Teesside at New Year's Eve. We're praying for a dry day, and if we get a dry day there, we should get it up to 18 psi, and 18 psi on a 1UZ with a 366 turbo. Looking at a couple of other guys on the internet that have done it, should be somewhere between 600 and 650 horsepower, and based on where it was at 16 psi in 4th gear, I think it's going to be an absolute animal, which is exactly what we wanted. So see you at Teesside, see you on the next video. Thanks very much for watching.